In this video, we're going to be talking about inheritance, and we're going to go over the terminology and a little bit about how to actually program inheritance in Java. So first up, what is inheritance? We're going to define it. We're going to define a couple terms related to it, and you'll have a little bit of the background you need to actually talk about inheritance as we move forward through this lecture. So inheritance is a set of abstractions. So we define an abstraction of a particular thing that we're trying to represent. So in this case, we're going to talk about inheritance with shapes. So our abstraction is going to be the shape class. And this class, this abstraction, is going to be known as a parent or a base class, and sometimes is referred to as the superclass. Then, after we have this parent class, we're going to define specializations of that abstraction, such as rectangle, circle, and triangle, which are all shapes, which derive certain characteristics out of a shape superclass. And these are going to be known as the children, child, or derived classes, and sometimes as a subclass. All right, so I've said subclass before. This is where we're going to actually talk about what subclasses are. A child class gets variables and methods from its parent's class, so they will have a lot of the same features. And a child class extends a parent in Java. Now, what's important to remember here, and we'll go over a little bit more about this later, is that your access modifiers in your parent class are going to be really, really important into how your child can actually interact with the things that it inherits. And we'll go over that a little bit toward the end of this lecture. So if we have an inheritance, let's say we have an employee, right? So we have an employee, uh, that's going to be our parent class. We're then going to have two children, hourly employee and a salary employee. Now, both of those are going to inherit things like receive pay or maybe their shift, things of that sort. That's going to be all associated with the employee class. But hourly is going to get a pay per hour, right? A hourly wage, and a salary employee is going to get a yearly salary. So they have two different types of pay, two different types of data values for that, and they're going to have to keep track of that data value on their own. Employee is not going to keep track of that. And then each of these might also have some additional subclasses. So we have the parent, which is the employee. We have the child, which is the hourly and salary employee. Now, these are children in relation to the original base class, the parent. We have the grandchildren of the original parent class, or the children of the child class, and this includes full-time hourly, so meaning that they get benefits, part-time hourly, which means they can't go above 30 hours. We have under salary employee, we have children such as an executive or technical staff, which have, again, different functions perhaps within their associated hierarchies. Now, on the last tier here, we have a great-grandchild, which have engineer, technician, and clerical, which are all part of the technical staff. They're all children of the technical staff class that I had mentioned. So you can see how they relate to each other, and what they inherit comes directly from their parent class. Now, something important to remember here is that there are things that are going to be inherited in that great grandchild that come from the original parent, right? So my original child will inherit things and it will pass what it inherited down to that lowest level, and it can keep going pretty much infinitely. So we can have as many child classes and great grandchild classes and so forth as we need in our program. And again, it's also interesting to note that we only get one parent, right? A class in Java can only inherit from one parent class. Now, when we're doing this, when we're writing new classes, we want to make sure that we override certain methods. So as we get new data, we want to be able to change how certain methods behave. We want to change their implementation details in our child class, and that's called overriding methods. This allows us to redefine how methods behave. Redefining a method from a parent and a child is useful for changing behavior based on child data on the child's data that doesn't exist for the parent. For example, with that hourly and salary employee, which was they were the children of the original employee class, we had different types of pay. We had an hourly wage and we had a salary wage. Now, the hourly wage, when they receive their pay, we also need to keep track of how many hours they worked. So we calculate their pay that they receive as their hourly wage times the number of hours that they worked. With the salary employee, they just get a flat amount every year, or more realistically, they get a certain amount every month that adds up to the amount they're supposed to get over the whole year. So how do you override a method? Well, you add the method signature to the child just as it appears in the parent. You can redefine the implementation here, and you can even redefine constructors. Now, when you redefine constructors, it's important to note that you do change the name of the constructor to match your child class's name. Now, there's some things you can do when you override a method. You can change the access modifier, but you can only do this to open up the access, not secure it down further, which means you can change a private to a public, but you cannot change a public to a private. This goes for both methods and variables. You can also change the return type, but there's only specific cases where you can do this. Generally, you can't change the return type, but you can change the return type when you're returning a class type. So for example, if we had that employee directory class that I had mentioned a while ago, then you can change the type of employee that you're returning in that getEmployee method that we call. If we're, for example, maybe making a getHourlyEmployee method, it could return a generic employee that happens to be an hourly employee, or we could tell it to explicitly return a hourly employee instead. And I'll go over what that might look like in an example. Overriding methods is also something you will need to do quite often. But sometimes we still, in that overridden method, want to call the original parent method, as it does some really nice things for us. It allows us to make sure that we're following the same setup and reusing as much code as possible from the original parent. To do this, you want to use the keyword super. So you'll use super dot the method name, or in the case of needing maybe a variable, it might be super dot and that variable name. But you usually use this with methods in particular. If you're trying to do this in the constructor, then you'll do just super with the rest of the constructor call like normal. So you won't do super dot the constructor name. You'll just do super and then the parameters for the constructor. And again, I'll go over an example of what this looks like. Now, with encapsulation and inheritance, we have some restrictions on the inherited members, and this is important because it allows us to make sure our data is secure. So with private data, the data with the private modifier cannot be manipulated directly. Instead, the children have to use the getters and setters, which are public, for accessing that particular modifier. So again, they cannot access that private modifier by name. Instead, they have to manipulate it in a little bit more roundabout way using those getters and setters. Children can also act like parents, meaning that the apple doesn't fall far from the tree. But when we do this, inheritance is a relationship, right? A circle is a shape, but a shape is not necessarily a circle. Child classes can be what we call upcasts, and we'll go over more about this when we get to polymorphism. But child classes can be upcast to their parent classes, which allows children to be used in place of a parent class. Parents cannot be used in place of their children, however, except when the parent is instantiated as a child. So you can see the example here where shape S equals new circle. This is an example of a child being used as a shape, but also as an example for a case when we might be able to use this shape as a circle explicitly. All right, so again, I'm going to go over an example of what some of this looks like in a demo video with code, and I'll give you the example files when I'm done with that demo video.